In this video, we will see how to enable or disable the cache of data that is accessed in the device when using online applications. There are several scenarios where caching is needed to store data in an application generated for smart devices. On the one hand, when we have an online application, meaning that it requires connectivity to perform, read, and write operations on data, we will want the data that has already been read in the server to remain in the device's memory. In this way, if the connection is lost, it's possible to keep showing the data on the application screen. That is to say, applications can be offline when reading data. The screens that haven't been opened, that is to say, those from which data has never been obtained, will be inaccessible. This behavior is automatically implemented by GeneXus in every application using an SQLite database that is included in all devices to store the information returned by REST objects together with the date in which this information was retrieved. On the other hand, to reduce the traffic between the client and the server, we can take advantage of the possibility to store already read data in the cache to avoid going to get it again when connectivity is restored when they haven't been changed. To solve this, for a query made from the device, we must know if the data involved in it has been changed since the last time the query was made. For this reason, the date of each query is saved on the device with a timestamp. In addition, the server also stores the date of the last modification that a GeneXus object made in each table and record. So, when a device has to load screen data, when invoking the corresponding data provider, business component, or REST procedure, it sends this timestamp. Before running the REST service, the server will have to compare the date received with the dates of the last modifications of data in the tables that have to be accessed, so as to decide whether to run the query again or not. Together with the server events, start if it's the first time, refresh, load, and send the data, or send an answer to client HTTP 304 that'll notify it that the cache data is the most recent. So it must use these ones. Note that in this case, the refresh and load events will not be triggered. But what happens if the data is changed using a non-GeneXus application? That is to say, an application that does not keep records of the latest change in the central database. Also, what happens if we need to run the refresh event to refresh the screen, for example, to have the variables reloaded even when the database data has not been changed? For example, in a screen that shows the country obtained from a web session and the sessions with speakers from this country, and the total number of speakers loaded. There's also a button to change the country in the web session and reload this panel that is showing the sessions with speakers from Uruguay along with the total. If we change again, this will be the expected behavior. Now let's see what we have to program in GeneXus to achieve this. Here we have the panel with a country name variable, the change button, the total variable, and a grid whose base table corresponds to that of session speakers. We can see that, in turn, the grid is filtered by this condition here, where the country ID variable will have to be retrieved from a web session. Therefore, in the refresh event, we will have to retrieve this web session value, search for the country name corresponding to this country ID, and also total the corresponding speakers who will be loaded later in the grid load. In the events, we have an invocation to the web session get method to retrieve the country ID stored in it. And here, we run through the country table to retrieve the country name. It'll be loaded in the variable shown on the screen. And over there, we're counting the number of records retrieved in this other for each command. To change the country, we click on this button that'll be associated with this event, Change Country. It'll call another panel called Ask Country, which will effectively change the country, and we'll do it in the country session variable. Next, when returning from this panel, a refresh will be made, where we will need to run the refresh event again to obtain the new value of the session variable, and then assign it to country ID. From this country ID, load the corresponding country name and display it to the user on the screen. Lastly, we'll need to total the number of records that will be loaded in the grid, and then load this grid with the new condition. But if caching is enabled, with this refresh a trip to the web server is made, which then sends the data of the last query made to the database. In the centralized database, if the country and session speaker values have not been changed by any other application object, the server will find that the date of the latest query made by this device is later than the date of the latest update made to the database. For this reason, the corresponding data provider where this refresh is located will not be executed. The data provider corresponding to the grid will not be executed either. Therefore, what we should see when pressing the button and changing the country is the same screen without any changes. Why hasn't this happened in our case? Because the Ask Country panel, which asks the user to choose the country through this dynamic combo box variable, is invoking the setCountry procedure that is sending this country identifier, the selected one. This procedure run on the server is the one that changes the session variable with this country. In addition, note that the cache is being disabled through the server API and validate cache method. When the cache is disabled, changing the country then causes the data providers corresponding to the fixed part and the grid to be reloaded. Note what happens if we add a comment. We press F5. Here we have the United States, and we will change it to Uruguay. As we can see, the screen has not changed, it hasn't been refreshed. By default, the cache will be enabled in all smart device applications. This means that when any query is made, for example in this panel, if the default value of the enabled data caching property has not been changed, every time that a refresh is made, due to the every time value of this property, and depending on the values of the latest update, the server will return the data by running the data providers corresponding to the fixed part and the grid, or will return an HTTP 304 message indicating that the data has not been changed. So, the panel will work with cached data. If we change the value of this property by setting it to false, every time that a refresh is made, the data will be brought again from the server regardless of the cached data. On the other hand, if we leave the property set to true, we can also change the property that indicates the frequency with which we want to check for new data. This can be done every time that the query is made, or after a certain time. In this case, it's 5 minutes. Here we indicate that if we're going to make a refresh, and the last one was made less than 5 minutes ago, cache data will be used. Otherwise, if more than 5 minutes have passed, the data on the server will be checked to confirm if new data has to be sent to it or if it hasn't been changed. This will be useful in cases when the query data will probably not change in that time period. In this way, we avoid unnecessary traffic between the client and the server. Lastly, we'll change the property value at the smart device's generator level by changing it to off. This will only work when the application has connectivity, because in that case, the query will always be made on the centralized database. But if the application is offline, in those screens where we have cache data, this data will be used. To sum up, we've studied how online applications handle the cache to read previously accessed data when they're offline, in order to avoid unnecessary exchanges of data with the server when they're online. In cases where, even though the data on the server hasn't changed, the refresh and load events need to be run again, an API to disable the cache is provided. As we will see later, offline applications always work on a database that is local to the device, and the exchanges of data with the server are made through synchronization programs.